sodium butanoate and undergo electrolysis. So it is a cold base electrolysis. So the basic reaction of cold base electrolysis is RCOO minus Na plus when it undergo electrolysis. So here initially it forms R radical dimerase RR and CO2. This is at anode plus NaOH plus H2. This is at cathode. So at anode alkane and CO2, at cathode NaOH and H2. So in the given reaction CH3, CH2, CH2, COO minus Na plus sodium butanoate electrolysis, and it gives corresponding hexane. By the dimerization we get hexane. Now hexane treated with Cr2O3 Al2O3. Not only Cr2O3 Al2O3, we can also take V2O5 Al2O3. We can also take MO2O3 Al2O3, and the temperature is 773 Kelvin and 10 to 20 atmosphere. 10 to 20 atmosphere pressure. So this reaction is reforming reaction and also known as aromatization. So if 6 carbons are present, minimum 6 carbons are present, it undergo first it forms cyclic compound, finally it converts into benzene. Now benzene treated with H2Ni and heat. So here only benzene is present, no other reducible functional group is present, only benzene is present. Generally benzene do not undergo reduction, but here only benzene is present, and we are doing this reaction at high temperature, therefore addition reaction takes place and finally corresponding cyclohexane will form. So this reaction is simply catalytic hydrogenation. Cis-2-butene, it is a cis-2-butene treated with Br2CCl4. It undergo anti-addition. So cis compound anti-addition, it forms corresponding racemic type product, racemic mixture. So how to write the racemic mixture here? Simple racemic mixture CH3 hydrogen Br. Cis compound anti-addition racemic mixture, and the corresponding enantiomer 2 methyl groups Br hydrogen Br. So this is a racemic mixture. Now it is treated with alcoholic KOH. So it is an alkyl bromide. So alkyl bromide when treated with alcoholic KOH, so we expect elimination reaction. And in elimination, since it is a strong base, first we expect even Cb, but in the given molecule even Cb not possible, but here E2 is possible, and we know that E2 is anti-elimination, and since it is a less bulky base, it forms stable alkene. Or Sage-F alkene. In this case, it forms corresponding Sage-F alkene as major product. So it is a alpha carbon, it is a beta carbon, it is a leaving group, and it is hydrogen. So do not remove the HBr directly. First this should be converted into corresponding Sahars. And after that we have to take the removal groups in the opposite direction. here hydrogen, and here Br. So it is called anti-periplanar geometry. So if the bonds are like this is called anti-periplanar, lie on the same plane and opposite side. And the corresponding groups are here bromine and here CH3, and here the corresponding products are CH3 and hydrogen. So Br comes here and H comes here. Now in the presence of alcoholic OH minus remove the proton. At the same time this bond will migrate like this. Therefore it gives corresponding product like this: CH3, CH3, opposite side Br and hydrogen. So we are getting the corresponding trans-alkene. We are getting the trans-alkene. So here we are getting trans-alkene. Again it is treated with sodamide NaNH2. It is a very strong base. Of course it is a stronger base than alcoholic KOH. Again here it is a alpha carbon, it is a beta carbon, alpha leaving group and beta proton. So again NH2 minus remove the proton through even E2 mechanism, and finally it gives corresponding alkyne. Finally it gives corresponding alkyne. So this reaction is similar to what we have studied in the class, vicinal dibromo compound. So here vicinal dibromo compound, when it is treated with alcoholic KOH, and in the second step we use a stronger base. We can also use alcoholic KOH, but NH2 minus is much better. And finally we remove the HBr and HBr, and we get corresponding alkyne. It is an alkyne treated with HBr. When alkyne treated with HBr, it undergo electrophilic addition. So alkyne react with H plus and form corresponding stable C plus. Now it reacts with the remaining Br minus, and finally it gives corresponding product like this. So because of C plus, Br minus can attack above and below. So here syn plus anti both are possible, but always anti-addition dominates. Now again it is treated with HCl. It is called vinyl bromide. It is a vinyl bromide molecule, vinyl bromide derivative. When vinyl bromide derivative treated with HCl, again alkene react with HCl. Again it is electrophilic addition and form stable C plus. Now it react with the remaining Cl minus and form corresponding geminal halo compound, geminal dihalo compound. If the functional group is connected to same carbon, that is called geminal carbon. Okay, so this entire reaction from NCERT point of view like this. When it is treated with HBr, so initially it gives corresponding monobromo compound. Again it reacts with HBr, and finally it gives corresponding geminal product. So this was we have studied from NCERT point of view in our class. We get geminal. So in this case also we have taken similarly. Now the final product is treated with, our final product is treated with strong base NaNH2 sodamide. So here we are having alkyl halide. So when alkyl halide treated with the strong base, it is a elimination, and of course here even Cv not possible, because it is a alpha carbon, it is a beta carbon. So if beta is connected to minus R, then only even Cb possible. Therefore in this case even Cb not possible, only E2 is possible. And of course here we have only one possibility, that is one alkene formation, no competition, only one alkene we are getting. And of course it is a proton. So NH2 minus, remove the proton. At the same time, good leaving group Br will leave, and finally we get corresponding vinyl chloride. Corresponding vinyl chloride derivative. Vinyl chloride derivative. Now it is treated with again NaNH2, because in the question it is mentioned as excess of NaNH2. Again anti-elimination takes place, and finally we get corresponding alkyne. Finally we get corresponding alkyne. Acetophenone. So acetophenone structure is benzene C double bond O CH3. It is a acetophenone. Acetophenone treated with nucleophile Hc triple bond C minus. It is called acetylide, because from acetylene we remove the proton. It is a acetylide. So ketone. So ketone undergo nucleophilic addition. Ketone undergo nucleophilic addition, and if I consider acidification grantedly, it gives corresponding product like this. Now this product is treated with copper 300 degrees Celsius and heat. So when it is treated with the copper, so it is a tertiary alcohol. We know that primary alcohol, when it is treated with copper or silver or gold, temperature 300 degrees Celsius, primary alcohol will be oxidized to aldehyde, secondary alcohol will be oxidized to ketone, and tertiary alcohol undergo dehydration and form corresponding dehydrated alkene. So in this case also it is a alpha, it is a beta. Since it is a tertiary alcohol, it undergo dehydration. It undergo dehydration. Now it is treated with Tollens reagent. Tollens reagent is AgNO3 NH4OH, otherwise AgNH32OH. It is called ammonical silver nitrate. Ammonical silver nitrate. So this is a test for terminal alkyne. It is a test for terminal alkyne. So here simply acid base reaction takes place with the terminal alkyne, and C minus will form, and C minus and Ag plus. It is a white PPT. So here alkyne react with Tollens reagent and forms white PPT. It confirms the reactant has terminal alkyne. So it is a test for terminal alkyne. Benzophenone. So benzophenone is pH C double bond O pH. It is a benzophenone. It is treated with PCl5. So here the keto group react with PCl5. So initially O lone pair attack, and finally we get corresponding product. Geminal dichloride. It is treated with sodium and ether. So this is a Woods type reaction. So it is simply Woods reaction. The basic Woods reaction is when alkyl halide treated with the sodium, it undergo dimerization, it gives corresponding alkane. Similarly in this case, because of two chlorines, so first Woods reaction, again Woods reaction. So two times Woods reaction takes place, and finally we get corresponding alkene. Now it is treated with H2SO4. So it is little bit interesting reaction. So here pH double bond pH. It is treated with H plus. Alkene react with H plus and form stable C plus. Now if I write the structure like this, then I can get idea. It is a benzene, positive, and it is a benzene. And if I see the structure, immediately I should recollect our basic reaction, that is, it is electrophile. So electrophile can attack on the benzene, electrophile can attack on the benzene. But this is a 3-member ring, that's why not favorable. But here 1, 2, 3, 4-member ring, it is favorable. Therefore, corresponding structure we can write, it is a benzene, it is a benzene, and here pH group, here pH group, and it is our electrophile. So like this, so electrophile simply. So this reaction, like in the class we have practiced the questions like this. If C plus is present here, simply this form corresponding ring. In this case also similarly it forms corresponding ring like this. This is one possibility. Another possibility is I am deleting this part. Another possibility is because of resonance, this carbon get positive, now this electrophile attack on the benzene, 1, 2, 3, 4, 5, 6-member ring, and it is our final compound. Again it undergo tautomerization to get aromaticity, and it is our final compound. So this simply can be written as, this structure simply can be written as 6-membered benzene and benzene. So it is also 6-membered ring and corresponding pH. So in a better way we can write like this. So these two structures are same, these two are same. Okay, so here 4-member ring formation and here 6-member ring formation, it is our best product. So it is our final compound, it is a major product. Benzene treated with succinic anhydride. So it is a benzene and it is treated with succinic anhydride. It is a succinic anhydride in the presence of H+. So here aromatic compound and it is anhydride, and we know that anhydride having the leaving group, therefore in the presence of H+, it produces electrophile. In the presence of H+, it produces electrophile. Now this electrophile reacts with corresponding benzene and electrophilic aromatic substitution takes place. Electrophilic aromatic substitution. It is simply electrophilic aromatic substitution. And of course we know that this reaction is Friedel-Crafts acylation. Friedel-Crafts acylation. Now it is treated with zinc mercury conc HCl. So this reagent combination is Clemmensen reduction. And we know that in the Clemmensen reduction only keto group will be reduced and acid group carboxylic acid do not undergo reduction. Therefore only keto group is reduced and carboxylic group remains as COOH. Now it is treated with PCl5. So this carboxylic acid react with PCl5. We know that the basic reaction, when carboxylic acid treated with the PCl5, it gives corresponding carbonyl chloride. It is simply nucleophilic substitution. In place of OH, we are getting Cl. Now it is treated with Lewis acid AlCl3 or ZnCl2 or BF3. You can use any Lewis acid. So because of addition of Lewis acid, it loses Cl minus, because AlCl3 remove the Cl minus and give corresponding carbocation. Now this carbocation react with the aromatic compound because it is a electrophilic aromatic substitution, and finally we get corresponding our Friedel-Crafts alkylated product. So this overall reaction again is also known as Friedel-Crafts acylation, not alkylation, Friedel-Crafts acylation. The reactant has one functional group, that is alkyl halide at bridge carbon leaving group at secondary carbon leaving group. It is treated with NaI acetone. NaI acetone. So we know that I minus is nucleophile. I minus is nucleophile. So here the basic reaction is when alkyl chloride or alkyl bromide treated with NaI acetone. NaI acetone. Finally, it gives the corresponding alkyl iodide and corresponding NaCl and NaBr. So this reaction happens because of this solvent. It is a polar aprotic solvent. We can use any polar aprotic solvent. In polar aprotic solvent, these are insoluble. These are insoluble. So these are precipitates. Therefore, because of this precipitate formation, reaction drives in the forward direction. Reaction drives in the forward direction. I minus capacity is, it is a strong nucleophile and as well as it is also good leaving group. I minus is a strong nucleophile and good leaving. So this reaction is known as Finkelstein reaction. This reaction is known as Finkelstein reaction. And Finkelstein reaction is simply SN2 reaction. SN2 reaction. And we know that if the leaving group is present at the bridge carbon, this carbon do not undergo SN1 reaction as well as SN2 reaction. The bridge carbon do not undergo SN1 as well as SN2 reaction. Therefore, only I minus attack at the chlorine connected carbon, and finally it gives corresponding iodide at the chlorine connected carbon. Now it is treated with AgNO2. AgNO2. We know the basic reaction when alkyl chloride or bromide or iodide. When it is treated with the AgNO2, we get mainly two products. One is RNO2, nitro compound. Another one is RONO. Suppose if I add KNO2, we get corresponding RNO2 and RONO. When we use KNO2, RONO is major. When we use AgNO2, RNO2 is major. Whenever Ag plus is present, it follows SN1 mechanism. So through SN1, it forms corresponding stable carbocation and it undergo migration. Why it is undergoing migration? Because among these two, because of minus I effect, it is a more stable C+. Now it reacts with the corresponding nucleophile and finally we get our major product NO2. Of course, we will also get ONO also, but I am writing the major product. Now it is treated with HNO2. And whenever we see HNO2 in entire organic chemistry, immediately we should think about electrophile NO+, nitrosyl electrophile. So this electrophile, especially if I see this reaction, so immediately I should recollect information like in case of tautomeric compounds. For example, if I take aldehyde, if I add H plus and electrophile, we know that the tautomeric proton replaces the tautomeric proton can be replaced by electrophile. It is simply electrophilic substitution. It is simply electrophilic substitution. Similarly, in this case also, this proton is tautomeric proton and we are adding electrophile NO plus. Therefore, immediately here the corresponding proton replaced with electrophile NO. Corresponding electrophile NO plus attack at the tautomeric proton. So this reaction is electrophilic substitution. Electrophilic substitution in tautomeric compounds. సో ఎప్పుడైనా టాటోమెరిక్ కాంపౌండ్స్లో ఎలక్ట్రోఫైల్ యాడ్ చేస్తే ఏ ప్రోటాన్కి అయితే టాటోమర్ రాస్తామో ఆ ప్రోటాన్ని మనం రీప్లేస్ చేయాలి విత్ ఎలక్ట్రోఫైల్. The reactant has alcohol functional group. It is alcohol functional group and alcohol functional group treated with NaBr in the presence of H2SO4. So the basic reaction is when alcohol treated with NaBr, Br minus in the presence of H plus, primary SN2, secondary and tertiary undergo SN1. Therefore, here the corresponding product is finally alkyl bromide. So since it is a secondary carbon, in the presence of H plus, it loses H2O. So initially it gives corresponding C plus. Now the C plus undergo migration and form corresponding stable C plus. Now it react with Br minus and finally we get corresponding tertiary alkyl bromide. Tertiary alkyl bromide. Now it is treated with bulky base tertiary butoxide and tertiary butanol. So it is a alkyl halide. Alkyl halide. And tertiary butoxide act as a strong base and also bulky base. Therefore here we have to think about elimination. And here E1CB not possible because it is alpha carbon, beta carbon. At beta position there is no minus R. So E1CB not possible. Only E2 possible. Since it is a bulky base and strong base, we should think about most acidic proton. And it is a secondary carbon, it is a primary carbon, and we know that primary carbon is more acidic than secondary carbon than tertiary carbon. In simple alkane type compounds, primary carbon is more acidic than secondary than tertiary. Therefore here the bulky base attract the proton, and the bulky base attract the proton. We get two compounds, one alkene like this and another alkene like this. We get two alkenes. First alkene is double bond connected to less number of substance, therefore it is called Hoffman alkene. Double bond connected to more number of substance, therefore it is a Sageff alkene. And based on mechanism here, since it is a most acidic proton, and of course bulky base approach the less sterically hindered carbon, that's why here Hoffman is a major product. Hoffman alkene is the major product. Now the major product treated with HCl in the presence of benzoyl peroxide. It is a benzoyl peroxide, pH C double bond O, 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 C double bond O, pH. So it is a benzoyl peroxide. So here we expect free radical addition, but this is not possible for HCl because for HCl there is no peroxide effect. There is no peroxide effect and there is no Karash effect. Karash effect because HCl bond enthalpy is high when compared to HBr. HBr peroxide effect observed, HCl not observed. Why it is not observed? Because of high bond enthalpy of HCl when compared to HBr. Therefore it undergo normal electrophilic addition, no free radical addition. It undergo normal electrophilic addition. Alkene react with H plus and form stable C plus. Now it react with the Cl minus and corresponding alkyl chloride will form. So it is our final product. It is a cyclic ether. When cyclic ether treated with Hi, 1 equivalent Hi, 1 equivalent Ha, so lone pair attract the proton, now it react with I minus. Since it is a tertiary alcohol, it undergo SN1, not alcohol, ether. Since it is a tertiary ether, so it undergo SN1 type of reaction. Therefore ring opening takes place, C plus will form, and here it is a stable C plus, no migration, ring expansion. Now it react with I minus and corresponding iodide will be formed. Now it is treated with reducing agent NaBH4. It is a reducing agent NaBH4, sodium borohydride. We know that alcohol do not undergo reduction, but alkyl iodide when treated with NaBH4, it undergo SN1 reaction. Since it is a tertiary in the given case, so it forms R plus, and R plus react with sodium borohydride, we get corresponding alkane. So in this case also, here we get stable C plus. Initially we get stable C plus. Now it react with corresponding iodide. Another possibility is also there. Lone pair can attack. Again we can get our reactant also. So this is also possibility. Both are possible. Since intramolecular, it can be considered as a major product. But here next question is carboxylic acid, and it won't react with the carboxylic acid. That's why I am considering this one as our product. Not iodide, here hydrogen. So this is our product. So our product is simply primary alcohol. Ether also possible because it is intramolecular. But here to continue the next reaction, we have to take the minor compound. Now it is treated with corresponding carboxylic acid in the presence of H plus. It is an alcohol, it is an acid, alcohol plus acid in the presence of H plus, Fischer esterification. Therefore here simply lone pair attack on the carbon, leaving group will leave, and finally we get corresponding carboxylic ester. Since this carbon is involved, this carbon stereochemistry do not change. So with respect to this carbon, we can say retention in configuration. With respect to this carbon, we can say retention in configuration. Acetone treated with concentrated H2SO4. So it is a aldol condensation. But here we have to consider 3 moles granted. So it is a acetone. And it is a acetone. So aldol condensation, and we get finally corresponding 1,3,5 trimethyl benzene. It is also called mesitylene. It is a aldol condensation. Now it is treated with excess of KMnO4, and KMnO4 is a strong oxidizing agent. Therefore the benzylic carbon undergo oxidation, and we get corresponding benzene 1,3,5 tricarboxylic acid. 1, 2, 3, 4, 5, 6. Benzene 1,3,5 tricarboxylic acid. It is treated with excess of PCl5. When carboxylic acid treated with the PCl5, so we know that carboxylic acid will be converted into carbonyl chloride. C double bond OCl, C double bond OCl, C double bond OCl. Simply it is a nucleophilic substitution. Now it is treated with excess of dibal. Excess of dibal, diisobutyl aluminum hydride minus 78 degrees Celsius is granted. So with excess of dibal, what happens? H minus attack on the carbon, leaving group will leave. H minus attack on the carbon, leaving group will leave. H minus attack on the carbon, leaving group will leave. Therefore we get corresponding aldehyde, aldehyde and aldehyde. And the final compound is 1,3,5 benzene, 1,3,5 benzene tricarbaldehyde. Tricarbaldehyde. It is our final compound. One of the reactant is benzaldehyde. Second reactant is acetophenone. Acetophenone. First compound is benzaldehyde, second compound is acetophenone. When these two reacted in the presence of base, so aldehyde ketones treated with the base either Cannizzaro or aldol. Of course here alpha hydrogen is present and this alpha hydrogen attack on the aldehyde, therefore it is a aldol condensation. So here the corresponding product is like this. It is a aldol condensation, crossed aldol condensation. So we have written the major product. So it is a alpha beta. In the aldol condensation we get alpha beta unsaturated ketone. And the reactant and the product name is, it is a benzol. It is a benzol and it is a acetophenone. Therefore the product name is benzol acetophenone. Benzol acetophenone. Now it is treated with N2H4 OH minus heat. It is treated with N2H4 OH minus heat, and this condition is hydrogen base. N2H4 means hydrogen. So hydrogen and base and heat. This is a Wolff-Kishner condition. Wolff-Kishner reduction. So for Wolff-Kishner reduction, to write the answer, remove the oxygen and write down the carbon ion. Remove the oxygen, write down the carbon ion. If any other possibility is there, we can consider, but here no other possibility. Even after resonance also we get same type of carbocation. That's why I am taking the acidification from water. Therefore corresponding product is like this. It is our second product. Now it is treated with Br2 heat. It is a alkene. So when alkene treated with Br2 cold condition or room temperature condition, it undergo electrophilic addition. Simply alkene react with Br2 and finally we get corresponding dibromo product. It is simply electrophilic addition. But the same alkene treated with Br2 and heat at high temperature, it undergo free radical substitution. It undergo free radical substitution, and we know that double bond next carbon is allylic carbon. This is allylic. With respect to benzene, it is benzylic. With respect to benzene, it is a benzylic, both allylic and benzylic. And here in the presence of Br2H nu, initially we get stable radical. Now the stable radical react with Br2 and finally it gives corresponding alkyl bromide. So it is our final compound. So alkene Br2 low temperature or cold condition electrophilic addition, alkene Br2 high temperature free radical substitution. The reactant has three ketone functional group. First ketone, second ketone and third ketone. Now ketone treated with excess of I2 and NaOH. So when I see this reagent and ketone, immediately we should think about halo form test. Halo form test. So in the halo form, the basic reaction is if the ketone is like this. So if it is undergo halo form, it gives corresponding product RCOO minus and CHX3. Here we are using the iodine, therefore iodoform, 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 and corresponding product is COO minus Na plus, COO minus Na plus, and COO minus Na plus. And here iodoform, iodoform, and iodoform. Now we are treating the compound with soda lime, NaOH and CaO heat. It is a soda lime. We know that when carboxylic salt or carboxylic acid treated with soda lime, it undergo decarboxylation. It undergo decarboxylation. Therefore, we should write the answer minus, minus, minus for decarboxylation, and after that acidification granted if no other possibilities are there. Now benzene treated with sodium and liquid ammonia. Benzene treated with sodium and liquid ammonia. Sodium and liquid ammonia. This reaction is Birch reduction. This reaction is Birch reduction. So in the Birch reduction, benzene undergo reduction and finally we get corresponding non-conjugate diene. Non-conjugate diene. So it is a Birch reduction. Suppose, try to remember this one also. If benzene connected to electron donating group, Birch reduction, corresponding answer double bond, electron donating group. So here one of the double bond with the electron donating group. Suppose benzene connected to electron withdrawing group, and the corresponding product is double bond, electron withdrawing group. Product is like this. So donating group, here double bond is present, withdrawing group there is no double bond here. So this is also Birch reduction. This is also Birch reduction. So try to remember the reaction. Sodium liquid ammonia, sometimes we also add along with liquid ammonia, we can also add alcohol. Ammonia to పాటు additional గా alcohol కూడా ఇస్తారు. The first reaction is iodoform, second reaction is soda lime decarboxylation, and third reaction is Birch reduction. Carboxylic acid treated with red phosphorus and Cl2. So for example, acetic acid when treated with red phosphorus and Cl2. So this is a HVZ reaction. So initially red phosphorus and Cl2 react, gives PCl3 and excess of Cl2. It is a Lewis acid, and from Cl2 we get electrophile. In the presence of Lewis acid, if I add electrophile, the alpha carbon of CH3, the hydrogen is replaced with chlorine, and chlorine attack on this carbon above the plane and below the plane. This reaction is known as HVZ reaction, Hell-Wohlhard-Jelensky reaction. Therefore, if the given compound is treated with red phosphorus and Cl2, the given compound treated with red phosphorus and Cl2, we get two compounds. One compound is Cl deuterium CH3 and another compound is deuterium Cl COOH and CH3. For example, this chlorine is above the plane this chlorine is below the plane. So it is alpha chloroacid. So these compounds can be written simply. For example, this compound CH3 COOH, above the plane Cl, below the plane deuterium, and this compound CH3 COOH, below the plane chlorine, above the plane deuterium. Now it is treated with AgOH. In the presence of Ag plus, it undergo NGP mechanism. Therefore, in NGP mechanism, retention in configuration. That means chlorine is above the plane, OH minus also above the plane. Similarly, in the second compound also, chlorine is below the plane, corresponding nucleophile also below the plane. Therefore, here neighboring group participation takes place. In the neighboring group participation, it follow retention in configuration. Retention in configuration. Now these products treated with PCl5. The final products treated with the PCl5. And here O lone pair can attack, alcohol lone pair can attack, and acid lone pair can attack. But alcohol lone pair is strong nucleophile. Acid lone pair is weak nucleophile. Therefore acid won't attack and strong nucleophile attack. And we know that with PCl5 it follow SN2 mechanism, and the corresponding product is CH3 COOH, Cl above the plane, deuterium below the plane, because here we have to think about inversion. So OH is below the plane, Cl attack from the above the plane. Similarly, next one, OH above the plane and corresponding nucleophile Cl below the plane, and it is also inversion. So in the given question, first one is HVZ reaction, L-Volhard-Jelensky reaction, second one is NGP mechanism, and third one is SN2 reaction. The reactant is phthalimide. This is a phthalimide, and phthalimide is a strong nucleophile, and here another reactant has leaving group. Therefore SN2 reaction takes place, and finally it gives corresponding nitrogen substituted phthalimide. It is a first product. Now it is treated with NaOET and benzyl chloride, PHCH2Cl, benzyl chloride. NaOET, OET minus is base as well as nucleophile, and we know that it is active methylene, and active methylene is more acidic than water. Active methylene is more acidic than water. Therefore OET minus act as a base, and here acid base reaction takes place, and corresponding nucleophile will be generated. Nucleophile will be generated. Now this nucleophile attack with benzyl chloride through SN2 reaction, and finally it gives corresponding product like this through SN2 mechanism. Through SN2 mechanism it gives corresponding product like this. Now the product is treated with H3O plus heat, and here if I see the molecule H3O plus heat, So we can look for the hydrolysis. Here hydrolysis, here also hydrolysis, here also hydrolysis, here also hydrolysis. Therefore, corresponding product is benzene, COOH, COOH. It is a phthalic acid. Now the remaining part is at nitrogen NH2, C, CH2PH, and this part COOH and ETOH, and this part COOH and ETOH. So of course here heat is also given, and alpha, beta, gamma. So beta gamma double bond is there, so decarboxylation takes place, and finally we get corresponding NH2, CH, CH2PH, COOH. So it is a alpha amino acid, and of course this compound name is alanine. This compound name is alanine. So this method is useful to prepare amino acids. Aniline treated with HNO3 H2SO4. This is called nitration mixture. This is called nitration mixture. When aniline treated with nitration mixture, it gives three compounds. One is OP directing ortho derivative only 2%, para derivative nearly 50%, 51%, and meta derivative 48%. Meta derivative 47%. So here we are getting meta significant amount. Generally NH2 is a OP directing, so we should get ortho and para major. Of course para is major, but ortho also should be major when compared to meta. But meta we are getting significant because when we are doing the reaction of aniline in acidic medium, some amount of aniline converted into anilinium ion. Some amount of aniline converted into anilinium ion, and which is meta directed. That's why here the meta also forming significantly because of this equilibrium. Now in the given question we have to consider major. So the major product is para. Now the para product is treated with NaNO2 and H2SO4. From this combination we get HNO2. From HNO2 we get electrophile NO+. So this NO plus attack on the nitrogen, and finally it converts into diazonium salt. This reaction is called diazotization. And diazotization directly proportional to basic strength. Diazotization directly proportional to basic strength. That means stronger base react faster in diazotization. Now it is treated with beta naphthol. It is a beta naphthol, and it should be not acidic medium, it should be in basic medium, pH 11 to 12, because phenol coupling reaction in basic medium only, pH 11 to 12, so slightly in basic medium. Therefore we know that phenol beta naphthol is aromatic compound and diazonium salt is electrophile, and it is a aromatic compound. Therefore we expect electrophilic aromatic substitution, and especially this reaction is known as coupling reaction. So beta naphthol undergo coupling reaction, and for beta naphthol especially electrophile attack at alpha position. Therefore the corresponding product is N double bond N, benzene, para position NO2, beta position OH. So it is a corresponding diazonic compound and which is a colored compound. Diazonic compounds are colored compounds. Glucose. Structure of glucose is CH2OH, CHO, OH right side, OH right side, OH left side, OH right side. It is treated with the conc HNO3. It is treated with conc HNO3. And the reactant is D plus glucose. And it is a aldose. Since it has 6 carbons, it is a aldohexose. When aldose is treated with the conc HNO3, the aldehyde and the primary alcohol both undergo oxidation. Aldehyde and primary alcohol, both carbons undergo oxidation without affecting the remaining alcohol groups. Without affecting the remaining alcohol groups. It is called glucaric acid. It is called glucaric acid and it is a saccaric acid family. Saccaric acid family. That means first carbon, last carbon, if they are COOH in the carbohydrates, that is saccaric acid family. Since it is a glucose, it is produced from the glucose, that's why it is a glucaric acid. Now the glucaric acid treated with excess of ammonia and heat. We know that generally alcohol plus ammonia, there is no reaction because this reaction will not happen because OH minus is not good leaving group. But we know that when carboxylic acid treated with ammonia, initially salt will form. Now it undergo dehydration and finally it gives corresponding amide. Therefore, in this case also, here salt will form and by heating it convert into amide. So it is a amide group and it is also amide group. And the remaining alcohol groups are unaffected. Now these are treated with excess of NaOBr. So we know that it is a primary amide. And the primary amide treated with Br2 and OH minus. Of course, in this case NaOBr, but we can consider simply Br2 plus OH minus. So here it is a Hoffman bromide reaction. Simply remove the CO group and write down the primary amine. So this is a Hoffman bromamide reaction. So ఇక్కడ మనకి మెకానిజంలో R మైగ్రేట్ అయ్యి తర్వాత నెక్స్ట్ హైడ్రాలసిస్ జరిగి ఫైనల్గా ఎమీన్ ఫామ్ అవుతుంది. Therefore here simply NH2 we remove the CO group and remaining same OH right side, OH left side and OH right side. And we know that when the same carbon having the ammonia and OH group, we can remove the ammonia. Therefore we can write the answer CH double bond O. So these two are the carbons and remaining OH right side and OH left side. So this is our final compound. The first reaction is oxidation. Next reaction is first acid base and then nucleophilic substitution type reaction. Next one is Hoffman bromide reaction. The reactant is ketone and having active methylene group. It is treated with I2 and OH minus. So we know that when active methylene group is present, so here we can break the bond like this. Therefore it forms corresponding product. This carbon will be converted into COO minus and this carbon will be converted into COO minus and the active methylene carbon will be converted into LOPPT iodoform. yellow PPT iodoform. So after acidification, it converts into corresponding carboxylic acid, COOH, corresponding carboxylic acid. Now it is treated with ammonia and heat. So it is a carboxylic acid treated with ammonia, carboxylic acid treated with ammonia. So initially it forms corresponding salt, COO minus, NH4 plus, COO minus, NH4 plus. Now it loses water from this part. And it gives corresponding phthalimide. Now it further reacts intramolecular SN2 type of reaction. Finally it gives corresponding phthalimide. It is a phthalimide compound. So it is second reaction. Now this compound treated with Br2NaOH. So imide also undergo Hofmann bromamide reaction. So this reaction also Hofmann bromamide reaction. So in this case what happens? I am explaining through mechanism. OH minus remove the proton, and it form corresponding anion. Now it react with Br2 and form corresponding N-bromo compound. Now it react with another OH minus molecule, nucleophilic substitution. Finally it gives CON minus Br and carboxylic acid. Now this CON minus Br will be converted into NCO, isocyanate. Since it is a base, it is acid, we are conducting reaction in basic medium, you can write COO minus. So the RCON minus Br. So RCON minus leaving group, it always converts into RNCO. So in this case also similarly we have written RNCO. Now it undergo hydrolysis. Finally it gives corresponding NH2 and COO minus, and the CO carbon will be converted into CO3 minus 2. Because of hydrolysis it converts into CO3 minus 2. So this is our final compound. So after acidification it converts into corresponding alpha amino acid. It is also called anthranylic acid. So imide also undergo Hofmann bromamide reaction. So simple ga మనం క్వశ్చన్ చేయాలంటే ఈ బాండ్ బ్రేక్ చేయాలి. Suppose if I want write the answer directly, so we can write here N minus Br COO minus. Now it undergo finally corresponding reaction. So ఒకవేళ డైరెక్ట్ గా ఆన్సర్ రాయాలనుకుంటే like that we can write. The reactant is tyrosine. So tyrosine treated with HNO2. So tyrosine is alpha amino acid. When alpha amino acid treated with HNO2, we know that here NH2 group is there. NH2 group undergo diazotization, and we know the basic reaction RNH2 treated with HNO2. It gives initially Rn2 plus, loses N2 gas, form R plus, and R plus react with water. Finally it gives alcohol. But if I take alpha amino acid alpha amino acid. This is NGP group. This is NGP group. Therefore, here the corresponding product is, the product is similar, but because of NGP group, it undergo NGP mechanism, and finally it follows retention in configuration. Retention in configuration. Because once plus is formed, if water is attacking, here retention and inversion both are forming. Retention and inversion both are forming. But in this case, whenever the NGP group is present in the alpha amino acids, retention in configuration, it is the only product which is forming in the reaction. That's why here through NGP mechanism, the product is corresponding alpha hydroxy acid. In place of NH2, we get our corresponding alcohol group. Of course, stereo not mentioned. If stereo mentioned, we should consider retention in configuration. Now it is treated with B2H6 and acetic acid. And we know that B2H6 has very strong affection towards carboxylic acid. Therefore, carboxylic acid undergo reduction. Carboxylic acid undergo reduction and it converts into primary alcohol. It converts into primary alcohol. Now it is treated with ketone and H2SO4, and here we are clearly observing the nucleophiles. So nucleophile attack on the carbon, nucleophile attack on the carbon. We know the basic reaction when ethylene glycol type of molecule treated with the ketone in the presence of H plus, we remove the water and corresponding product like this. So in this case also acetal formation takes place. So it is our final compound. It is our final compound. So first one is diazotization, next one is reduction, next one is cyclic acetal formation through nucleophilic addition. The reactant has ether functional group and aldehyde functional group, and it is treated with concentrated OH minus. So we know that when ether treated with OH minus, there is no reaction. But when aldehyde treated with the OH minus, there is a possibility of aldol or Kenizaro. Aldol or Kenizaro. And aldol is possible if alpha hydrogen is present. Kenizaro is possible if alpha hydrogen not present. Therefore here ether won't react, and this aldehyde no alpha proton, this aldehyde no alpha proton. Therefore it is an example of Kenizaro reaction. It is an example of Kenizaro reaction. And in the Kenizaro reaction, OH minus attack on the aldehyde, but we have to select the most reactive aldehyde. Since it is a plus R group, and plus R group donate electron density at ortho and para position, because of this carbon has less positive charge because donating group decreases positive. So relatively this carbon has more positive charge. Therefore OH minus preferably attack at this carbon, do not attack here. And finally where OH minus is attacking, that carbon undergo oxidation and remaining carbon undergo reduction in the Kenizaro reaction. OH minus attacking on the aldehyde, and that aldehyde undergo oxidation and the remaining aldehyde undergo reduction. Now it is treated with concentrated H2SO4. Now we are seeing clearly here acidic part and alcohol part. So COO minus in the presence of H plus convert into acid. It is a carboxylic acidic part and it is an alcohol part in acidic medium, and acid plus alcohol in the presence of H plus. This reaction is known as Fischer esterification. Fischer esterification. Therefore, the final compound is simply here esterification takes place. It is a corresponding lactone. So simple lone pair attack avutundi, leaving group వెళ్ళిపోతుంది. So cyclic ester is known as lactone. Now it is treated with dibal. Whenever dibal is given, minus 78 degrees Celsius is granted if temperature not mentioned. Therefore, dibal H minus attack from the dibal on the carbonyl carbon and leaving group will leave, and finally it gives corresponding aldehyde and alcohol. So it is a dibal reaction. So in this question, sucrose on acidic medium hydrolysis. So we already know that when glucose and fructose, beta D glucose and alpha D fructose, beta D glucose at C1 carbon, alpha D glucose at C2 carbon, if I remove the water, we get corresponding sucrose. By removal of water. Suppose if I do hydrolysis, again they will give corresponding glucose and fructose. Therefore here, because of sucrose hydrolysis, we get glucose and fructose. Of course, after hydrolysis, we will get alpha and beta both because of hydrolysis mechanism. So glucose and fructose. Sucrose on hydrolysis gives glucose plus fructose. Now this mixture treated with Fehling solution. In the glucose mainly we are having RCHO. So it is a glucose part. So when it is treated with the Fehling solution, so in the presence of Fehling, aldehyde undergo oxidation, COO minus, and Cu plus 2 undergo reduction, forms Cu2O red PPT. Now if I consider acidification granted, corresponding carboxylic acid. It is a glucose part. Therefore, glucose part is like this. Only the glucose aldehyde part is oxidized. But when it comes to fructose, fructose do not undergo oxidation directly. So initially what happens here, tautomer is possible, and because of tautomer it forms enediol. It is called enediol. It is an alkene and diol. Now it undergo tautomerization. It gives two types of compounds when it undergoing tautomerization, because this hydrogen attack on this carbon from the above the plane, from the below the plane. Therefore we get two compounds. Therefore here hydrogen left side, it is a glucose, and of course we also get mannose. సో ఈ ప్రోటాన్ మనకి ఈ కార్బన్ మీద అటాక్ అయినప్పుడు అబోవ్ ద ప్లేన్, బిలో ద ప్లేన్ అటాక్ అయితే, ఫర్ ఎగ్జాంపుల్ హైడ్రోజన్ అబోవ్ ద ప్లేన్ అనుకుంటే, ఇక్కడ హైడ్రోజన్ బిలో ద ప్లేన్ అనుకుంటే, సో ఈ కాంపౌండ్ ఏమో గ్లూకోజు, ఈ కాంపౌండ్ ఏమో మ్యానోజ్. సో ఫ్రక్టోజ్ ఇన్ ద ప్రెజెన్స్ ఆఫ్ బేసిక్ మీడియం gives glucose plus mannose. Similarly, glucose in the presence of basic medium gives fructose plus mannose. Similarly, mannose in the presence of basic medium gives glucose and fructose because of formation of this intermediate enediol. Now it undergo Fehling reaction, and this undergo Fehling reaction, CHO converted to corresponding acid and CHO converted to corresponding acid. Therefore, ketones give Tollens-Fehling-Benedict test, but they do not give directly. They convert into aldoses and then respond positively to the test. సో ఇక్కడ మనం ఆల్రెడీ గ్లూకోజ్ రిలేటెడ్ కాంపౌండ్ రాసాం కాబట్టి, సో ఫ్రక్టోజ్కి ఆక్సిడేషన్ చేసినప్పుడు గ్లూకోజ్ రిలేటెడ్ కాంపౌండ్ ఫామ్ అవుద్ది, ప్లస్ మ్యానోజ్ రిలేటెడ్ కాంపౌండ్ కూడా ఫామ్ అవుద్ది. సో మ్యానేజ్ రిలేటెడ్ కాంపౌండ్ లైక్ దిస్. It is a mannose related product. So glucose related is gluconic acid. Mannose related is mannonic acid. Glucose related is gluconic acid. Mannose related is mannonic acid. Now it is treated with red phosphorus HI. And HI. We know the basic reaction. When CO bond is present, if I treated with the red phosphorus and HI, CO bond will be converted to CH bond. Therefore here CO bond, CO bond, CO bond, CO bond, CO bond, CO bond. Therefore the CO bond undergo reduction. Finally it gives corresponding N-hexane. Finally it gives corresponding N-hexane.